So today what we're going to be doing is we're going to be doing this. We're going to be graphing parabolas by using tables. Now, how do we know if we got it? We use tables of values to graph and state the domain and range. Now what we're going to do is we're going to take a look at this graph that we have on our sheets, and we'll talk about all the key points, features of the graph. The first point is it's curvy. So if you look at the graph, you'll notice it comes down and goes up, and the second graph starts from the bottom, rises, and then goes back down. It's just curvy. You'll notice that the graph opens up or down. So the first graph starts up, goes to the bottom and goes back up, starts below, and then goes back down again. Now, the most important part of every parabola is this low point and this high point for the second one. Basically, the lowest and highest points on these graphs are called the vertex. So this, for my parabola opening down, is my vertex for that graph, and this point here is for my second graph opening up. I want to stress this a lot. All parabolas have a domain which is equal to x such that x belongs to all real numbers. And the reason why that is if I took a look at this parabola. So this parabola here, as I move all the way to the left, I can find points. If I walk straight up after I find my lowest x value, I walk all the way up, I can find a y value that matches it. The same can be said if I move all the way across. I could find a point way off the screen that would end up on my parabola. So the moment I can do that, if I know that I can choose any x I want, I say that x such that x belongs to all real numbers. That's what that set means. Now, all parabolas have that. All parabolas that open up and down. You'll also notice that this parabola, the purple parabola, starts really high, goes down, and then goes back up. That means we have a minimum value for our y values. And we also have for our red parabola the fact that we have a maximal value. So what we have for our fifth point is that basically when we look at our vertices for each of these parabolas, basically our maximum value for y will occur at our vertexes. You'll also notice that if I ever decided to, I could split this parabola exactly in half, the purple parabola exactly in half. And you'll notice that this imaginary line that I'm drawing here, that would split this parabola exactly in half, literally goes through the vertex. And the same can be said about this parabola here, my red one. So basically, if I drew an imaginary line, I could have literally this imaginary line splitting my vertex in two, and thus having my parabola split in two. So the sixth point of every parabola is basically all parabolas are symmetrical at the vertex's x value. Now, let's discuss where parabolas are often used. Parabolas are used when anytime we're taking a look at a business. It's all about the money, if you think about it. Money is what makes businesses run. Money causes businesses to spend more money to make money, or they spend less money. Also, money also affects people who are spending to buy things. So for example, let's say I had a graph that represented basically the quantity of stuff that I could sell. But then also I have a price value. Now this is all from the perspective of the business. Now, if I could control my quantity, basically what would happen is our business, as we increase the price, the amount of money that I make increases. But as my quantity of stuff that's in the market increases, basically what happens is eventually we make too much and then the price starts to drop. So in a market that has a lot less stuff, the price rapidly increases for that product until we reach a maximum, an equilibrium point. And then if we increase the amount of stuff that we are selling in the market, it tends to drop after that. So we literally can have a maximal point that looks similar to a parabola. Some people call that a property of Keynesian economics. Now, when we're talking about physics, we talk about basically parabolic flight. When we're talking about parabolic flight, we're literally talking about things like taking a ball and kicking it. So imagine, example, if you kick a ball into the air, imagine we decide to kick a ball into the air or along the ground. You'll notice that as time passes, the ball rises, reaches a maximum, and then comes back down at exactly the same rate. So if we actually had a time and height graph, it would look like a parabola. As a matter of fact, Newton's principles that we learned years ago in math class, in physics class and science, is all based on that. All right.